So file and directory permissions on Linux systems are quite different from what you may be used to or what you would expect. And to be honest, it's not very intuitive the way that they work, but it's just how it is, and we have to understand it and we have to use it on Linux systems. And there's some more advanced permissions that can kind of help get rid of some of the non-intuitiveness of file and directory permissions, but we'll get into those later on in the administrator part of the course. For now, it's just important that you understand basic file and directory permissions. And first off, there's 3 different ownership properties of every file and directory that you need to know. First off, there is user permissions. Every file is owned by a user, and then also has a primary group ownership for every file and directory on the system. And the permissions that apply to every file and directory are read, write, and execute. And read, write, and execute permissions have a completely different effect on a directory versus a file. And we'll talk about that here in just a second. So there's read, write, and execute permissions for the user who owns the file. There's read, write, and execute permissions for the group that owns the file. And there's read, write, and execute permissions for other. Other represents anyone and everyone else on the system, all other user accounts on the system. So that is a total of 9 different basic permissions that you need to be familiar with for every file and directory, as well as understanding the effects of read, write, and execute on a file versus a directory. Now, the effects on a file. The read permission on a file allows you to read the contents of the file. For instance, if it's a text file, if you want to be able to read what text is in that file, you have to have read permissions on the file. Next is write. Write permissions on a file allow you to edit or modify that file. So if you want to change the contents of a file, delete some text or add text to a file, or something like that, you have to have write permissions on the file. Execute permissions on a file allow you to run the file or execute it as a process. For instance, if you had a script, if you wanted to execute that script, you'd have to have execute. If it was a binary or an executable file, you'd have to have execute permissions in order to execute it. Now, permissions on a directory. Read permissions on a directory allow you to see the contents of the directory. It allows you to basically run the ls command on a directory and see what files are inside of it. If you don't have a read on a directory, you cannot see what files are inside the directory. Write permissions on a directory, and this is what trips up most beginner users on Linux. Write permission on a directory allows you to delete or add contents to the directory. So write permissions on a directory allow you to create new files in the directory or delete existing files inside the directory. And that's very important to understand. Whether or not you can delete a file has nothing to do with the permissions on the file. You can have all the permissions on the file or no permissions on the file at all, and you can still delete the file if you have write permissions on the directory that the file is contained inside of. So it's very important. Execute permissions on a directory allow you to traverse the directory. And what I mean by traverse the directory is it allows you to go inside of the directory, for instance, cd into it, or do an ls of the directory, or do an ls of a subdirectory within that directory. So in order to go past that directory at all, with any command, whatsoever, you have to have execute on it, or else you cannot traverse into or beyond that directory. You do not have to have read on a directory in order to traverse a directory. You just won't be able to see what's inside of it, but if you know the name of a file that's inside of it, you can still access that file. So hopefully these different permissions will make a little more sense when we demonstrate exactly how these permissions work. The other important thing about permissions is I said that we have 3 different types of permissions. We have the user permissions, read, write, execute, group permissions, read, write, execute, and other permissions, read, write, execute. The most specific permissions are what's applied when you're trying to access a file or directory. And what I mean by that is, even if other has full read, write, execute permissions on a file, which means everyone on the entire system can modify the file if they wanted to. If the user permissions did not have write permissions, the user who owns the file would not be able to modify it. Even though everyone else on the system can modify it, the user who owns it cannot modify it. It works kind of like an access control list from the top down. What it does is it checks the user permissions and says, are you this user? Yes or no. If you are, then it looks at the permissions and determines whether or not you have permission to read it or write it, and it doesn't look any further. From there, it doesn't look at the group permissions and it doesn't look at the other permissions. It looks at the first one that it matches and it doesn't go any further. So keep that in mind as well. Now let's go in and look at some of the permissions on a file. So user permissions. Here I created a test directory with a few different directories and files with various different permissions on it that we're going to take a look at. I'm currently located in /temp/tester, and the permissions on this directory that I'm in, tester, are here. So it's owned by root and the group root, and the permissions for the user who owns it are read, write, and execute, which we can see right here. The permissions for the group that owns it are read and execute. So if you see the dash there, that means they do not have that permission. And the permissions for all others on the system are read and execute. So as the user student, we're not root and we're not in the group root. So in this case, we're considered other, which would be the last set of permissions on that directory. That means that we have the ability to read the contents of the directory, which means we can do an ls of it. So ls/temp/tester, which works. And we also have the ability to traverse the directory, which means we can cd into the directory essentially, which we're already there. But let's take a look first at the long listing of the ls output. Being able to interpret the output of ls-tacl is important when we're working with permissions, because that's typically the easiest and best way to get what the permissions are on a file or a directory. Now, if you just wanted to do an ls-tacl on a directory to look at the permissions, you need to add the tacd option, and I'll show you why here. So for instance, let's say we wanted to get the permissions on the directory I'm in right now, /temp/tester. If I do an ls-tacl of /temp/tester, it's actually just going to give me a long listing output of all the files that are inside of that directory, not the directory itself. But if I run the same command with tacld, we see that it actually gives me the permissions of the directory itself. So that's useful to know. So going back to the long listing output, we've already mentioned in previous demos that This first letter on the line here, that indicates what type of file it is. In this case, we have 1, 2, 3, 4 directories, and if you have no letter at the beginning, that means it's a regular file. That's a typical file. And if we run the file command on unot-modify, we see that that is an ASCII text file, so that is a regular file. The next 3 characters on the lstack-l output, that is the permissions for the user who owns the file. So for instance, on this file here, these 3 characters, these 3 are the permissions for the user student. And how do we know who owns the file? This is the owner, right here. That's the user who owns the file. This is the group who owns the file. So these permissions right here are for the user student, and these 3 characters here are for the group student. And the last 3 are for other, or anyone else on the system. We don't really need to worry too much about any of the other stuff. There is some other information you can get from this, like the last time that the file or directory was modified, or the actual size of the file, as well as the number of hard links on the system. But for now, we're really just focused on permissions, so let's just stay focused on those. Okay, so let's go through a couple different examples here. So right now, I am the user student. If I type who am I, we can see I am the user student. Now, we also want to type the ID command. The ID command is going to give us some information about what other groups may we be in. So if we look at groups here, we can see that we are in the primary group of student, which is group ID 1001. Every user that's added to the system automatically has a primary group created for them that is the same name as their username. But we're also members of the group wheel, which we'll talk about later on in the course, but that's essentially the administrative group on RHEL 7 or CentOS 7 systems. And then we're also a member of a group called UMBC with a group ID of 75,000. So this first directory, can_rm. Now the reason why you see it highlighted in neon green is because of the fact that it is world writable, or basically all other has write on the directory. Anytime other has write on the directory, it highlights it in green just to kind of warn you or let you know. Oftentimes there's not a whole lot of reasons why you would make a directory and give a directory write for other, meaning anyone and everyone on the entire system has the permissions to add or create files or delete files in that directory. So that's why it's highlighted that way. So this directory just has write and execute permissions for the user root, the group root, and all others on the system have write and execute. However, no one has read. And because no one has read, that is a directory, which means you need read in order to see what's inside of it. So if I do an ls on can_rm, it says permission denied. Now, one thing that's important to note is that the root user, regardless of the permissions, if root is the user or the group, even if the file had no permissions, root can always do anything they want with a file, even if they don't have the permission. So just to show you what's inside this directory from the root user's perspective, I'm going to use the sudo command, which means super user do. It basically allows me to run a command one time with administrative privileges, just to kind of show you what's inside there, because as the user student, we can't see what's inside there. We get permission denied. So sudo ls tac l can_rm, to type the password